In this video, I'm going to show you how to set up a reflux condenser in order to do a reflux on a reaction. Now, reflux of a reaction is the process by which we maintain a solvent at its boiling point so we can heat a reaction mixture efficiently and thoroughly without losing solvent to the atmosphere. Now, if we were heating a reaction mixture with a volatile solvent in, say, a beaker or an Erlenmeyer flask, and we needed to heat it to the boiling point of the solvent, eventually all of our solvent would just evaporate. Now, the nice part about a reflux condenser is it cools the reaction. Well, it cools the solvent by jacketing the path with cold water, such that it traps the vapors, cools them down, and causes them to condense and fall back down into the reaction mixture. Now, this loses its efficacy when we have to heat to extremely high temperatures. Sometimes we have to use very cold water. You may have set up a recirculating pump with an ice bath, but for most purposes, cold tap water is sufficient to cool down the reaction mixture, well, the solvent, enough to cause it to condense and fall back down into the reaction mixture. So what we're using here is our West condenser. So this is the thicker one, not the distillation column. And I have two tubes coming from it. You'll see that this tube on the bottom is connected to the sink, connected directly to the sink. So the water will come in the bottom. This is going to be vertical. It'll come in the bottom, fill up to the top, and then this tube is going back into the sink to drain. And I'm going to make sure it's really in there so I don't get splashed with water. I've also gone through the trouble of copper wiring them just so the tubes don't come flying off when I turn the water on. Now, it's important to put the inlet on the bottom and the outlet on the top. If you put the inlet on the top and the outlet on the bottom, it'll fill up this much, just a little bit, because it'll fill up a little bit and then drain out immediately. You need to make sure it's filling up from the bottom up in order to have the most efficient and full cooling power of the jacket. Now, the jacket is on the outside. From this bottom part, it goes into an inner column, and that's where the solvent vapors are going to be traveling up, hitting the walls that are cooled by the water, condensing, and then falling back down into the reaction mixture. So this is, again, an efficient way to make sure we don't lose solvent when we're heating a reaction to high temperatures. We're going to leave the top open. If we were to plug the top, say with a septum or a thermometer adapter, we would build pressure in the system, and we'd essentially be creating a high pressure system that could explode. It might pop off all the glass pieces, but it does have the potential to explode if we start building up pressure in the system. So we always leave the top of a reflux open. Now, it can be attached to other things, but somewhere along the way we have to have an open port so we can equalize the pressure and not build up pressure in the system. This is our first organic setup, and the thing to remember is fritted glassware always gets greased. So this is a frit. Now, both the round bottom flask and the reflux condenser are fritted, meaning it's a frosted glass surface. If we do not grease the joints, and that means every joint that we connect with fritted glass, if we do not grease these joints, we run the risk of what's called freezing the glassware, where some solvent gets in between the two pieces of glass, cools down, and causes the glass pieces to essentially lock together. Freezing glassware can result in having to break the glass or having to throw out the pieces. Either way, it's not a good idea. So we want to make sure we grease it. Now, I have silicone grease here. You really only need a little bit. I'm going to put a couple dots on it. It's very thick. I'm going to put maybe 4 dots, 3 or 4 dots all the way around. And then what I'm going to do is I'm going to take my round bottom. Now, this would have my reaction mixture in it. I have it empty right now, but this would be the reaction mixture that I'm looking to reflux. So solvent and some kind of reaction that's happening. I'm going to take it and put it on the end. I'm going to twist it. Now in twisting it, the grease will spread, and what we're looking for is a clear view through the two pieces of glassware. This means there's an even layer of grease all the way around and that the seal is complete. It is less sensitive to have a complete seal for something like this, but if you don't have a complete seal, again, you're losing solvent vapors through the glass joint, and you end up evaporating some solvent away. In an extreme case, if you're doing air sensitive or water sensitive chemistry, having a non-tight joint will ruin your reaction mixture. So I'm going to so I now have a clear joint in between here. There's no streaks. That means I have a good joint. You won't hear the glass scraping against one another. It'll be a smooth, you'll feel it and you'll hear it, that's a smooth joint. I'm then going to take a Keck clip of the appropriate size. In this case, the blue one is the appropriate size. I'm going to snap it on. So the keys between every fritted glass joint are we need to grease it, every fritted glass joint, and we need to have a Keck clip to secure it. So the Keck clip prevents it from coming apart. If it was just fritted glass with grease, this could slide out, but the Keck clip will keep it together. So now we're ready to do our reflux. So I'm going to stick my reflux condenser in the power mite. Now I'm using a power mite and a heating mantle for this. Depending on what temperature you need to heat it to, you can use a water bath, you can use a sand bath. Advantages of using a water bath are then you can do it on a hot plate with stirring. If I'm using the heating mantle, I can't stir it, so I'm just expecting it to mix as it boils. If stirring is something that I need, I would opt to use probably a water bath on a hot plate. So my reaction mixture is in the round bottom flask. I have my my reflux condenser set up with it open at the top. I have the water coming in at the bottom and out at the top. What I would do next is I would turn on the water. Now, again, probably a good idea to copper wire each tubing place where the tubing meets a nipple, just to make sure you don't get sprayed with water. But we are ready to turn on the water, so I'm going to reach over here and turn on the sink. And you'll see that the water filled up from the bottom and is now coming out the top. It doesn't need to be an extreme flow of water, but you do want it to be enough that it's circulating cold water through here so it can cool it down efficiently. It looks like mine has a little bit of a leak, which we're not doing a reaction, so it isn't a big deal. Once my water is on the condenser, I'm safe to turn on the heating mantle or hot plate or sand bath, oil bath, whatever I'm using, and start doing our reflux. What you'll notice is as the reaction mixture, the solvent will start to boil, and it'll start to create a ring of vapor. It literally looks like a ring or a line across the column where the vapor is hitting the walls. It's getting cooled by either air or water in the jacket and starting to condense and drip back down. As you heat it, and again you can heat it well above its boiling point since we're going to trap it up here, you'll see the vapor line moving up and up and up, but it should not go all the way to the top. Now, if you heat this too high or you overheat the reaction, you run the risk of it not being cooled enough by the water and just coming out the top, and in that case you just have an open beaker that you're evaporating all the solvent. You're aiming to keep your condensation ring in this portion of the reflux condenser, in the bottom half. That ensures that the cold water is going to hit it when it comes in, keep the solvent condensing and falling back down and dripping into your reaction mixture. Reflux is a good way to keep reactions going for a sustained period of time, say an hour, 2 hours, 3 hours, and you don't have to worry about losing solvent in that time. You can go do something else and you know that all of the solvent will be there when you come back. At the end of my reaction, I would turn the heat off and I would turn off the water. And you saw a little bit of water kind of go everywhere. I'll deal with that. The water will drain out and you simply need to take this apart. You let it cool down before you take it apart, and then your reaction mixture would be good to take on to the next stage of your reaction: extraction, separation, quenching, further reactions. Wherever you're going with this reaction, this would be done at this stage now.